Oh.
Good morning, ladies and gentlemen. Thank you for joining us at the Rosatom Waste to Energy webinar, where we give an overview and an African perspective. Before we start, I'd just like to do a few webinar considerations. Attendees are reminded to ensure the volume is turned up on their device. Ensure you have a stable internet connection. This will ensure the streaming and audio will run smoothly. Attendees can ask questions via the questions panel located within the GoToWebinar control panel. By default, the control panel is located on the right-hand side of your screen. The chat function is reserved for webinar organizers and panelists to communicate with attendees. Attendees will not be able to chat with each other, however, are encouraged to ask questions. A recording of the presentation will be made available on the SAIEE YouTube channel, SAIEE TV. The recording will also be made available on the SAIEE website under the Events drop-down menu in the section Past Events and Webinars. This page is updated regularly, so ensure you check back as often as possible for new uploads and subscribe to our YouTube channel for uploads. A certificate of attendance will be issued a few days after this webinar. I'd like to now introduce you to the CEO of Rosatom South Africa, Mr. Ryan Collier. Ryan Collier joined Rosatom Africa in October 2014 with the task of promoting the Rosatom brand as well as driving public awareness of nuclear in the region. Since then, he has been advanced to a progressively more responsible position of CEO of the company. He boasts a wealth of experience in commercial and technical communications as well as strategic business development. Mr. Ryan Collier, welcome.
Thank you very much, Minx. Can you hear me?
Yes, we can hear you. Thank you.
Fantastic. Super. Thank you so much for the opportunity, as always. We really do appreciate working with SAIEE. And today, I think we've got a very exciting webinar on waste to energy. So just a little brief on Rosatom. Rosatom is the Russian state-owned nuclear corporation. We encompass around 350 companies and employ roughly 270,000 people. Our core business is obviously big block nuclear power plants. However, we have diversified our portfolio into various energy sources, and waste to energy being one of them. We really believe that waste to energy is vital in Africa. Africa has an energy problem that we can't deny. Everyone is well aware of this. And Africa also has a waste problem. So we really see waste to energy as a solution that comes in and fits the bill and solves two problems at the same time. And it's for this reason that we've actually partnered with Hitachi Zoysan. Urs will explain who they are later, but we've partnered with them on African projects, and essentially we would be the main equipment manufacturer under Hitachi's world-renowned design. They've produced many of these or constructed many of these facilities across the globe, so it's very reference technology. And we're very proud to have a partner like Hitachi on these projects. So I'm not going to take too much of your time. Urs is the best person to explain all of this, and I really do hope you have a fantastic webinar. If there's any questions for Rosatom Central and Southern Africa, unfortunately, I won't be able to answer them later on. But please do send them via email, Minx, and we will gladly answer them. So without further ado, I think I'll hand over to Urs Ultenburger from Hitachi, and he'll be able to give you a fantastic explanation on waste to energy and how it fits into Africa and what we're able to offer together. Thank you very much, everyone.
Thank you, Ryan. Take care. Ladies and gentlemen, you will now see on the video, we have both Mr. Urs there together. But I'll introduce both of you. The first one, Mr. Urs Ultenburger, which is on the right-hand side of the screen. Mr. Ultenburger has more than 15 years experience in sales management in a global industry. Since 2012, he has been the head of international sales for Hitachi Zoysan Innova and is responsible for business development and performance of all sales activities. Currently, his main focus is on promoting waste to energy technological solutions to emerging markets in partnership with Rosatom subsidiary Atomenergomash. Mr. Ultenburger has a wealth of experience in interacting and procuring new clientele through frequent travel to regions and markets for client acquisition, relationship, networking, and business development purposes. Our second presenter is Mr. Urs Gespacher, who is the CEO of AIL Finance. Mr. Gespacher manages the company and is board member. He also oversees the structuring of various projects and export financings. He arranges equity and debt capital and manages investments in various commercial and contracting projects. Before his current role as the CEO of AIL Finance, Mr Gespacher was the Senior Vice President of ABB Structured Finance Advisory in Zurich. He managed a profit center project and was involved in export and structural financing business in the power generation and transmission, oil and gas, and transportation sectors. At ABB Structured Finance AG in Baden, he managed the advisory team, strategic, operative, and financial management of a profit center and the ABB Group company. I hand you now over to both our panelists.
Good morning to everybody. Can you see my screen?
Yes, it's perfect. Thank you.
Perfect. Okay. So as we are introduced, we would like to speak today about waste to energy towards a sustainable future. It has a long time ago started in Europe and it starts in Africa now as well. We see all over some activities now. So we would like to present to you what we can offer together in a group of companies and how we think Africa is moving towards a waste to energy to a cleaner future. Myself, I'm Urs Ultenburger. I'm from the company Hitachi Zosen Innova. The company is a joint venture with a Japanese company, so we are a Japanese-Swiss corporation. The head office in Europe is in Zurich, Switzerland, and the head office in Asia is in Tokyo and Osaka. And we have some other subsidiaries in all over the world, since these plants are built in many different countries. Atom and Ergomash, it was introduced by Ryan, so we do not need to speak more about this. It's our partner company, mainly focusing on the manufacturing of the boiler, having some equipment done, do some engineering. Then we have the company AIL Structured Finance. That's my colleague next to me. It's also Urs. We are all called Urs in Switzerland, so it's easy. So he can quickly explain what his company is doing for us.
AIL Structured Finance is a small advisory, a financial advisory boutique headquartered in Zurich, and we focus on structuring and arranging funding for energy infrastructure and other capital goods projects. And we cooperate since many years with HZI, and we support HZI and HZI clients in structuring and arranging funding solutions for waste to energy projects.
Then quickly an overview of what is built in the world by us. So you can see here mainly the Western and newly now also Russia. So there is a lot of plants being built waste to energy because it's a very it's a solution to produce energy from a free source of energy. So it's you can see that we have a lot of plants in the Europe. Our market share is 34%, so we are the #1 company for such projects in Europe. In the whole world, you can see that we are now expanding to Australia, where plants are being built. If you look Eastern Asia, there is a lot of plants. That explain why we are a Japanese-Swiss company, because in Japan alone, there are 215 plants built, compared to Western Europe, complete of 195 plants. So the reason for is in Japan, it's an island. They have no space for the waste, for landfilling, and they need energy as well. So it is a very big boom there. In Europe, at the moment, the biggest market is England, because they were a little bit behind the Central Europe, and they build a lot of these plants currently. The core competences of our groups are development and engineering. we can, as Urs explained, we provide financing solutions, which is a very important part for such large infrastructure projects. Then we build such plants on turnkey basis or as EPC, or we only provide systems, for example, only boiler and grate. It's depending on the demand of a customer. And we also do a long-time operation and maintenance, or we also own plants. Like, for example, the latest is the plant in Dubai. It's the biggest plant in the world being built right now. And this plant we own and we also operate over 30 years. As I said, it's our key business is waste to energy, and the typical plant looks like that. So the key parts or sections are the grate combustion, then the energy recovery, the flue gas treatment, very important today, and the residue treatment. So every plant has also residue, so there is no zero waste. And all the surrounding, like project management, engineering, and execution, that's also part of our business. So we fulfill the full scope of building such a plant. Then we looked at Africa. As I said, currently in Africa, there's only one plant existing in the southern African part. But if you look in this chart from the World Bank, you can see that already today that Africa produces more waste than the whole Europe, and Africa also have the 58 fastest moving or fastest growing cities in the world. So waste is becoming more and more a problem in Africa, for health, for the space, for the environmental, wildlife, and so on. So it's time that Africa starts to change the policy regarding the waste handling. Here in a chart, you see Southern Africa. The waste is produced, so there can be a lot of thermal plants built. There can be a lot of sources for new energy. As we understand in South Africa, you have a lot of these energy lockdowns and shutdowns. So it's a very good way to add to a reliable energy source. And as I told, in Africa, there is so far in this big continent only one plant existing, and that's in Ethiopia. It was completed some years back. It's quite a big plant, and it was built by a joint venture company, UK-based Cambridge Industries and the Ethiopian government. So that's the only plant in Southern Africa. So in the northern African part now, it starts in Dubai, in Oman, in the Emirates. So they start to build such plants now as well. Then for such plants, a very important part, or probably the most important part besides the technology, is how you finance such a plant and what is legally required that you can build such a plant. And I hand over to Urs. He can explain this part.
Good.
Even mit dem Maus drehen. Oder so.
Oops. As Urs Ultenburger just explained, basically the start for any project is always a good and reliable technology. But then on top of that, for a successful project, there are various other elements which are needed beside a good technology. On the one hand, we have environmental issues, we have the socio-economic impact, we have the entire world and field of waste organization and management, we have the legal and regulatory framework under which waste organization, waste disposal are operated, and last but not least, the question is always, how is such a plant financed? And then hopefully as a result of all these elements, a project becomes economically and also socially viable. All these all these elements are needed and need to be ticked off in order to have a successful project in the end. Good. If we now focus for a moment on financing as one of the key elements, obviously long-term financing for this type of very long-term project is key. And depending on in which markets a project is going to happen, in such markets, often liquidity and long-term funding is a scarce resource. That's why in a lot of tenders for such projects, financing is part of the tender, and the supplier needs to come up with solutions not only in terms of technology but also in terms of long-term financing. And as it is clear for everybody, long-term financing is indispensable for the economical feasibility of a project. Now let's maybe look into various possible or potential project structures in which such a large energy from waste project can be implemented. The easiest and straightforward structure you can see on this slide now, basically a municipality or a utility or a municipal entity acts as buyer and operator of a project. And such entity needs then to have secured waste supply with long-term contracts. On the output side, you need long-term contracts in terms of electricity sales and residue sales. And obviously, in order to be able to operate the plant, first you need to build it. This you do under an EPC agreement, and depending on how you are equipped and what the know-how is within the utility or the municipality, you do O&M on yourself, or you outsource that to a specialized O&M contractor. And as Urs said, Hitachi also can be active as O&M contractor, not only as supplier of the plant. Then, the next structure which might be possible depending on the project, on the environment of a project, is that basically a municipality in need of A, energy, and B, waste disposal services sets up a special purpose company which the municipality itself owns and provides an equity stake. That can be arranged separately, and here it is then very important that the contractual setup provides for all the requirements and needs of the debt financiers, which is very important, the waste input contract, and also obviously the output side, electricity and heat and residue sales. That's another way to structure a project if the municipality does not take it directly on their own balance sheet. Then, if we continue, the slightly more complicated structure is a BOT, a PPP, a BOO, or a BOOT structure, depending on really the details how you set up a project. Here, the municipality, which basically needs energy from waste or wants to do waste incineration, outsources almost everything under a long-term concession agreement. Private sponsors, private entrepreneurs set up a special purpose company, finance these companies, and basically provide the services required under concession agreement to the municipality. Later, maybe after 10 years, after 15 years, after 20 years, the plant is handed over to the municipality, and the municipality can then operate the plant on their own. This structure ensures that the municipality, to start with, just has to basically agree and sign a concession agreement, and the rest is then being done by private companies, financing privately, operation privately, all the negotiations of the relevant project contracts done privately. In terms of financing sources, debt financing sources for projects in Africa, there is a whole range of sources of debt finance and also credit risk insurance available. It very much depends on the location, on the country of a project, on the project participants, who is the sponsor, who is the municipality granting the concession, and this drives then what type of debt financing is available. But one can say that in most of the African countries, debt financing is available, obviously subject to proper structuring of a project along the lines we just have discussed in the structure slides.
Good.
Yeah. Then the question is always very quickly, either by the municipality or by a project sponsor, well, good and nice debt financing, but what is a typical pricing and typical terms of and conditions of such financing? If we take as an example an export credit agency covered debt financing for a given project in Africa, the first question is always, can we achieve really long-term funding, long-term debt financing for a project? Because a plant has an economic life of maybe 30, maybe even 40 years. So one cannot finance such an undertaking with a 2-3 year loan. That doesn't make any sense. So as an example here, you can see on the slide, these export credit agency covered schemes can have a repayment period of up to 15 years, plus then obviously the construction periods, which is typically 3 years. So you have an all-in duration of the debt arrangements of 18 years. The interest margin you pay, now we are at the moment in a euro-denominated environment, is maybe 1.5% to 2%. The base rate at the moment is close to 0, and together with the insurance premium you pay for the export credit agency, you then have an all-in or an overall debt pricing of slightly below 5%, which for this type of project is quite an attractive pricing and supports the economic viability of a project.
Thank you, Urs. So we can move on to one project we are busy with now outside of South Africa. It's in Tanzania, in Zanzibar. And we just want to show you shortly the structure of this project, how it's done. It is in the South Island in Zanzibar. The plant is built in a very lean structure with only necessary buildings where it's needed to cover, because of course the climate allows to do that. Not like in Europe, we have not there is no winter or strong demand for having warm buildings. So it's a very lean and a low-cost plant. And the project structure, Urs can explain quickly how the structure looks like.
As you can see here on this slide, we intend to structure the project in a project finance setup with a special purpose company acting as owner and operator of the project. And as you can see on the upper part of the slide, the equity is coming from various shareholders. One on the left-hand side is a Zanzibar private company, and then quite important for any project, if needed and required by a client, also Hitachi Zosen Innova can act as a minority shareholder of the project, which adds quite some credibility to any project. Then we have other private investors, and we are at the moment discussing with the government whether they want to take also a minority stake in the project. Then the most important contract on the chart you see in red is the concession that the special purpose vehicle needs from the government to build, to run and to operate this project. then there is need for a long-term waste supply contract with very defined and very detailed gate fee arrangements. Then we have an electricity sales contract with the local utility, and as you can see, very long-term due to the long-term nature of the project. And the plant is being delivered by a consortium of Hitachi Zosen Inova, AEM, and a civil company. In terms of operation and maintenance, there will be support of HZI and other specialized companies. This is a typical project finance setup, which then enables the SPV to arrange roughly 75% of the capital expenditures of the project to finance this 75% with long-term debt.
Just to give you a view on the size of this plant, so it is the availability per year is 7,800 hours. So it runs these hours and produces energy. The megawatt production is 11.5 megawatts, and the capacity is 180,000 tons of municipal waste per year. Of course, in African countries, often you have the problem that the calorific value, that means the fuel you put in has a lot of biological waste. Therefore, the calorific value is rather a bit lower, and that's why the efficiency of such plants is also a bit lower. This we can leave. Important is, of course, by such plants as well, the flue gas emission. It has to be to the latest norms available in Europe, for example, the BREF limits, which are now since 2020 in force, and they are very strict. So we build the plants complying with this regulation. Then we move over to South Africa. What's happened in South Africa? Is it moving towards waste to energy? We made a comparison, Switzerland in 2017 and South Africa in 2017. So you can see that we produce 8 million tons of waste per year. Our population is around by 8 million, and South Africa produces 42 million tons per year. And I think your population is also in the range of 45 million. Such an industry creates a lot of new jobs if you build such plants, because it's the waste to energy plants, but there's a lot of other plants attached to it. So the waste to energy in Switzerland, that business created over 25,000 jobs. It generates a turnover of 1.5 billion euro per year, which is a big amount of new money which a country can generate. And in Switzerland, we have around a recycling rate of the waste by 50%, which is very high in comparison to other countries in Europe. That means 50% of the waste is going back into the flow in the industry, and the other 50% you can do actually nothing with it. You need to incinerate it or destroy it. If we compare to South Africa, currently you are around by 11%. That means from the 42 million, you only recycle about 4.9 million tons. So there is a lot of improvement as well to have a recycling industry built up. With our waste in Switzerland, we provide heating to 1 million households, and we generate electricity for about 650,000 households. Waste of energy plants also avoid the emission of millions of tons of CO2, so it's a good thing for the environment as well. If you look Switzerland, it's quite a small country, but we have built 38 of these plants, and attached to these plants is a lot of recycling plants, other specialized plants serving these plants. So it's around of another 100 different manufacturing plants. important by such plants when we build them, like we do in Moscow or in Australia now newly, or in the Middle East, it's very important to have a lot of the equipment produced in the country where we build them. So that means, for example, we would build in Tswane or wherever in South Africa a new plant, we would then look for local sourcing to build the boilers, to the filters, etc. Everything what can be made in South Africa will be made there. We provide the engineering, and the production will take place there. So it's also giving work during the construction period. It will allow the industry to produce a lot of equipment. To get a picture how big such plants are and how much steel goes in it. So it's you can see the duration of construction is around 3 to 5 years for such a plant, depends on the size, depends on the country. Then it's around 50,000 of steel, tons of steel worked into the plants. At maximum peak, we have around 850 workers on the site. It's around 140 kilometers of power cables or of control cables, around 100. Drawings to be done is around 19,000. So it's rather big projects, and they will take time, and they need to be positioned well in the country, to be on the right place. And it serves a lot of industries. That means they have a lot of disciplines which can be supplied to this project. Then we go further. There was the first waste to energy plant in South Africa, well developed. Let me say it like that. It was in the Nelson Mandela Bay Metro, also in Port Elizabeth. And this plant was very well developed by the consulting engineering company Royal Haskoning, together with the Dutch company. And this project even received the guarantee from the Central Treasury of South Africa. Everything was set up well. The plant was sized to be around by 180,000 tons per year of waste. The energy production was around by 15 megawatts, which was supposed to be directly fed into the municipality of Port Elizabeth. And the project was very well built up. It was a whole waste park, actually. It consisted of a biomass plant, of a waste to energy plant, and some other plants like recycling and so on. You can see here on the left-hand side top, that would have been the waste park, which is a very good concept done by Royal Haskoning. And we did participate for the waste to energy plant and for the AD plant. The emission values you see below, which we had to follow, which is not a problem for such plants actually today, but still the emission that the flue gas treatment is quite sophisticated, and in these days the biggest part of the plant. And you can see the plant exists of a great combustion, of the steam boiler, heat utilization, and the flue gas treatment. The contract was awarded to Hitachi in 2016, and it was supposed to go in operation in 2019. And what happened to this plant in South Africa? You had a lot of political issues there between the two political parties, ANC and ND, I think. And so this project was certainly cancelled. It was not realized until today, unfortunately, even though it was at a very good basis. The financial model was working. It's a pity that this project failed to realize. And also we can say that of course for an investor like Hitachi, it's a poison if you have political instability. Then we come to the technology. So the great boiler technology is the most common technology used for waste to energy. It is simple, it's reliable, and I would say 98 or 90% of the plants in Europe, the big plants, are all based on the gray technology. Then you have the fluidized bed. This is another type of process. It's more used for a bit smaller plants, maybe with a more similar waste characteristics. It's not that common, and it requires a very good sorting and preparation facility in front of the plant. And we have the type of gasification, but this is not really used for waste, for municipal waste. It's a process also always coming up, but it's not really suitable for such type of wastes. And the problem by fluidized bed and by gasification, you need a very expensive pre-treatment of the waste. You cannot just, like in a great incineration, you can put in anything you want. And by this type of processes, you need a very sophisticated pre-treatment, which also is expensive to operate. What is important if you start to build such a plant? You need to really select the right technology. You need to have a right contracting model. You need to check what contractors you use with the history track records. But you need also to think these plants, they should operate, like Urs said, for 40 years without problems. So it's very important to use really reliable technology with a lot of experience. You can see from England there is a lot of plants built by newer companies which run into troubles and of course creates a lot of a mess and creates a lot of financial problems. Energy from waste, it's a free source of energy actually. So you can see 1 ton of waste creates around the same value like 200 kilogram of crude oil, can provide electricity, 700 kilowatt hours electricity, or give energy and heat to households. So it's a free source of energy, which currently in South Africa you put in the ground, and it is better actually to use and to convert into energy. And then, of course, what you have in South Africa, very big landfills. I believe you want to close them now also by law. The problem with landfills is, of course, it can pollute the groundwater, like we have in Switzerland, still suffering from landfills 40 years back. We have to take out again because they pollute our groundwater still today. You cannot do really energy recovery from a landfill. And then if you have a fire on these illegal landfills or have a fire, it pollutes, of course, the air. So it's not a good thing to have them. And many countries in Europe, they have today the law zero landfills for municipal waste. So it's not any more common to have them. Maybe still in the southern part of Europe, you still have it. And then we talk about recycling. So it is very important also that you can recycle waste. You can take a lot of, like you have in South Africa, a lot of waste pickers. So the people taking the waste, but you can do it also in a business, in a plant, to sort it and put it back into the industrial streams. But there will be always waste which you cannot use anymore, and this, for example, contaminated paper or any type of waste you can just not use anymore, and this has to be destroyed, and this normally you feed into a waste to energy plant. So you have ecological reasons, you have economical reasons to do so, and there is also political reasons to do so. It makes sense to explain the population that the waste is also converted back into the streams, are not only all destroyed. So then in an energy for waste plant, what you have to put in and what you get out. So it's basically you have to put in the waste, and you have to put in some additives like lime or natrium carbonate for the flue gas treatment. That's basically what you need to put in, and out you get energy. You get the bottom ash. This is mostly used again, or can be used again from brick manufacturing or street constructions. And then you have the cleaned flue gas that goes into the environment, the air. And you have flue gas cleaning residues. This is around 1% of the plant, and this needs to be treated specially, because that is the residues from the flue gas treatment which takes all the toxic out. So this has to go into a controlled landfill. On the financial side, what you need to create some revenues to finance such a plant. So you will have a gate fee. People need to pay, or municipalities need to pay to this plant owner a fee per ton, per waste going there. And of course, you can sell the energy to the ESCOM or to the metros in South Africa. Or you can also sell the steam which you produce, or you can sell both in combination, steam and electricity. It's depending on the place where the plant is positioned and on the requirement. The new emission norms, they are very strict now, which are in force now in Europe for such plants. So they are much stricter now than the previous ones. But still, these plants are designed that it's not a problem to achieve them. Then we have an example to show how important it is what type of waste you burn. Municipal waste can be, if you don't do sorting, the calorific value is rather low. And what does that mean? It means the plant is producing less energy than a plant which has a more high calorific value. So typically in Germany, Switzerland, we are around by 10,000 kilojoules per kilogram, or even above that. In England, it's a little bit lower. So it all depends what type of waste you feed into the plant. So for example, you have seen Zanzibar, we calculate there on 9,000 kilojoules per kilogram. And you can see on the red and purple and green figures what is the effect on the output of the plant. So of course, the higher you can bring the calorific value, the better for the electricity output. And how to achieve that is, for example, you can the best way to achieve to raise the calorific value is you sort out the biological waste, garden waste, or such type of waste, take it out and do composting, not burn it, and then you automatically have a higher range of calorific values. So the solution is actually that you reduce the waste by around 90% of your country, in your country. So it's a very big reduction of waste. And you destroy harmful substances through the process of incineration. You concentrate the harmful substances in a very small amount. This is very important to know. So it's not distributed over a big area. It is very controlled. Then, of course, recycling of ecological, economical values. And, of course, the energy recovery from a free source of fuel. On the picture, you see a plant built in the middle of a city, in the city of Lausanne. They can be built in the middle of cities, so it not needs to be in a suburb or industrial area. They can be in the middle of Paris, for example. It's not a problem today. The current projects we are working on, you can see here, it's Newhurst in the UK. They are busy building now. In Dubai, this is the biggest plant ever built in the world. So it's a very massive plant. and it burns nearly 2 million tons per year of waste. And this is a plant which Hitachi with some partner owns and operate for over 30 years. Then we have in Australia, which is a similar climate to South Africa, we build a new plant in East Rockingham. It's also, Australia also starts to convert now from landfill into incineration plants, which is a new trend there. So we have received the first order there. The plant produces incinerates 300,000 tons per year of domestic and industrial waste. Then Rookery South in the UK is a plant just under construction now. Ivry in France, this is also rather a big plant. Then in Moscow, the Russians, and that's why our cooperation we have with Atomenergomash or Rosatom. In Russia, they have a different concept. They plan one plant and they multiply them by 4 in Moscow. So it's 4 times the same plant around in the suburbs of Moscow. And each of the plant have exactly the same design. So this gives some advantages in the cost of such a plant, because you have the engineering only to do once. You have the same material used, the same suppliers can be used. So this is quite a good approach, typically for Russia. So, and that's big plants. Each of the plant produces 700,000 tons per year and adds electricity of around 70 megawatts each. 75 megawatts each. It's not thermal. Okay. Then we are busy in a plant in Mexico. Also very big plant, nearly as big as Dubai. So we are in this developing phase there. In Latin America, it's also not the typical continent for waste to energy plants at the moment, but it starts to wake up now. We are busy commissioning now in Istanbul, in Turkey, the first plant in Turkey. The plant has 3 lines. It produces 1 million tons per year. The plant in Dublin, Ireland is completed. It's in operation now. Then we have a plant in Poland. It was commissioned 2016. It's very similar to the size we did offer in Port Elizabeth. Then we have a new plant built in Switzerland, because in Switzerland most plants are over 40 years old. So the new generation comes now. The older plants are shut down and new plants arise again. This is a very highly sophisticated plant, which any customer from South Africa is welcome to visit such a plant. Well, that's around it from our side on waste to energy. So you are welcome to ask any questions or write to us or. Yep. Minx, are you there?
Yes, I am just, thank you very much. I was just trying to find my unmute button. I encourage our attendees to ask questions. We have one question from Mr. Ed Bunch asking, what is the cost per kilowatt hour produced?
Per kilowatt hour. Sorry, can you repeat the question?
What is the cost per kilowatt hour produced?
Well, that depends a little bit. This is difficult to say, but I can answer it in a different way. You can say depends on the country, depends on hourly rates in the country. When you build such a plant, you can calculate between 400 euro to 700 euro per ton of waste treated. So you will know what is the investment for such a plant. and then you can convert it back to the electricity you produce.
Great, thank you very much. We don't seem to have any more questions. So, and I can just encourage our attendees to, if they have questions, to please send it to myself, minx@saiee.org.za, which I will then forward to our presenters. And then what, we have another one here before I sign off. We have here from Mr. Sicelo Mabuza, are there any plants produced outside of municipalities?
Yes, there is, of course. If you are a company, you want to build such a plant, and you have the sources to get the waste from the municipality or from whatever. Of course, you can build such a plant, and there is some we call them merchant plants. So the owner of the plant is, like we have in Dubai, is for example Hitachi in a consortium, and then the plant is ours, but we take the waste from the municipality. So you can own such plants, yes.
That is excellent. Thank you very much. So that is the only questions we have for today. So just to inform our attendees that the recording of this webinar will be uploaded on the SAIEE TV plant. I thank you everyone for attending today, and both our presenters, Mr. Ultenburger and Mr. Gespacher, thank you for your time. We really appreciate it. Oh, wait, I've got another question for you. Sorry. This is quite an important one. Do you facilitate funding?
Yes, we do that. And typically a lot of clients who are interested in building a plant with Hitachi Zosen Innova technology also require support in arranging financing for a given project, and HZI regularly supports the client also with arranging funding, be it equity funding or debt financing.
Excellent. Thank you very much. So that was our last question. And thank you for your time, for joining this webinar today. And we will definitely be in touch again. But your presentation will also be uploaded together with the recording of today onto the SAIEE website. Thank you very much, gentlemen. Have a good day. All our attendees, thank you for joining us today. Take care.
Bye-bye.
Thank you very much.
Thank you. Bye-bye.
So